All right, for this passage 6, we're going to do it just like we've done the other science ones. And remember that we're not going to try and look at all the graphs and memorize all the numbers and blah, 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 right? We're just going to look at the intro, get a little handle of what they're talking about, and then go from there, look at the questions, and find our answers in order to save time and be as efficient as possible. So it says 3 studies examine how the volume of runoff from melting ice is affected by wind speed and by the pressure of sand beneath the ice. In a lab kept at 18 degrees Celsius, runoff was collected from a plastic box containing melting ice. The box was tilted at 10 degrees and had horizontal openings on its lower end. After flowing through the openings, the runoff fell into a trough and was conveyed to a measuring device. So basically, the water melts, drips down here, comes out of a trough, and then they measure how much water comes out. Now, this one says right here, in each of the first 3 of 4 trials, the following steps were carried out. We can go ahead and read this since this applies to all of the tests except for one. It says a 30-centimeter deep layer of a particular clean, dry sand was placed in the box. A 30-centimeter deep layer of chipped ice was placed in the box on top of the layer of sand. A fan was turned on to blow air at a constant speed onto the trough end of the box. For the next 600 minutes, the volume of runoff collected over each 20-minute period was measured. And they have the wind speeds. In the 4 trials, all of the steps except step 3 were carried out. So the fan was not turned on. Okay, so let's go ahead and look at these questions. So 34. Let me make sure I didn't skip a question. Okay, 34. The researchers conducting the studies chose to use a box made of a type of plastic rather than of wood to ensure that all the water from the melting ice would flow from the box and into the trough. The researchers most likely made the choice because that type of plastic, unlike wood, is... Okay, so why would we use plastic instead of wood? And the best answer... is it's not porous or permeable and therefore incapable of absorbing water. It's G. Okay, so porous means it has holes. Permeable means things can pass through it. Plastic does neither, so the water cannot get into it. There's one of our rare science questions that doesn't come straight from the text. It's more of a vocabulary question. 35 says, suppose study 2 had been repeated except in a lab kept at negative 1 degree Celsius. The total volume of runoff measured over the 600 minutes in the repeated study would most likely have been what? Now this one here, we can take a look at study 2. The second trial of study 1 was repeated. Then the second trial of study was again repeated, except that step 1 was omitted, no sand. Okay, so they run it with sand and without sand. And you can see that without sand, it melts a little quicker. Okay, the sand can act as a thing, but in this case, we don't even care about that. The key thing here is that it's at negative 1 degree Celsius. Wow, this one's got a bunch of stuff that you're just supposed to know. Water freezes at 0 degrees Celsius. So what would be the expected result if the lab is at negative 1 degree Celsius? In other words, freezing cold. Well, the expected results would probably be near or at 0. So regardless of kind of what study they're doing or what other things they're looking at, right, the temperature is the thing that matters here. Okay, question 36. According to the results of study 1, for which of the wind speeds did the runoff volume per 20-minute... For which of the wind speeds did the runoff volume per 20-minute decrease to 0 from its maximum value before 500 minutes? wow, okay, volume per 20 minutes. Oh, because it's measuring every 20 minutes. When does it decrease to 0? Excuse me, before the 500-minute mark. So let's come here and take a look. Okay. So it looks like we've got the 500-minute marks right here, and it looks like the circle track and the diamond track are the ones that have reached their 0 point before the 500-minute mark. So the circle and diamond, those are our 2.5 and 1.0 wind speeds for meters per second. So 36, that's going to be J. Okay, 37. Compare the results of the two trials in study 2. In which trial did the volume of runoff per 20 minutes reach a greater maximum value? And in which trial did the volume of runoff per 20 minutes decrease to 0 from the maximum value in a shorter amount of time? Okay. So just looking at this one, study 2, so we have the layer with sand and the layer without sand. The one with sand had a higher peak, or sorry, without sand, excuse me, that's the open circle there. Let's erase this. Has a higher maximum value, and it goes from about there to decrease, whereas this guy here with sand looks like it peaks about right here-ish, right before 100, and then goes all the way till there, which is a larger distance. So when we come down here, in which trial did it decrease to 0 in a shorter amount of time? So we want one where the without sand had the greater maximum value and it decreased in a shorter time. So it's going to be D for 37. 38. The volume of runoff measured at 200 minutes in study 1 for the 4 wind speeds is best represented by which of the following graphs? So they're going from lowest to highest wind speed, and we want to look at what is the runoff at 200 minutes. So let's come up here and look at 200. So that's right here. So it looks like the lowest one's going to be 2.5. So we got something like 2.5 as the lowest. Then about twice that much is going to be the square one right here, which is the 0 miles per hour. And then just above that, the two that should be about the same will be the other two. So that's the 0.5 and the 1.0, which I just realized I wrote these in the wrong order. We can here we go. So let's grab this and move it over here. There we go. Okay, so something that sort of looks like that. So let's come down here for question 38. The best one that matches that is, oops, I'm still on the cut thing, is J. That one looks like my little graph that I drew here. Wow, it's an exact replica, basically. Okay, 39. Which factor was varied in study 1 but kept the same in study 2? So remember, study 2, this is the one where they took the second trial of study 1 and did it once with sand and once without sand. So what would be the varied in trial 1? Well, they were changing the speed of the wind, whereas in study 2, they were keeping the wind the same, and instead they were varying the sand. So which factor was varied in study 1 but kept the same in study 2? That's going to be the wind speed. So that will be B. 40. Based on the diagram and the description of study 1, which of the following expressions would most likely be used to calculate the volume of the sand layer of the plastic box before chipped ice was placed on top. Okay. Well, let's come up here. So we're going to have to know that our box is 120 by 60 centimeters wide. And I believe, yes, it tells us that 30 centimeters of stuff is placed. So volume, from math, we can remember that it's equal to length. Oh, I forget. Length times width times height. So in length, we just said is the 120. Width is the 60. And in this case, the height is 30. So 120 times 60 times 30, that's going to be G.